It's going to have to get downloaded anyway. All right, so welcome to Monday's office hour. I'm here with Christy one-on-one. She's the only one that showed up. So, and by the way, we went over her test and I gave her half credit just for coming.
Yay.
So if you would like to get some credit, come talk about your test. Make an appointment with me. All right, or come to the office hour and we can do that. All right, so just a reminder, we've got the test at the end of the week. So we're going to do some hypothesis testing. Christy said that we're going over the ANOVA test. ANOVA stands for Analysis of Variance, which is a little bit of a misnomer because all it is a test where you, instead of doing, so we've done one mean, we've done two means, we've done paired means, we've done a mean with the standard deviation and a mean without the standard deviation. So we're up to like 5 or 6 tests now. And so the tricky part of the test that's coming up at the end of the week is trying to figure out which test you're supposed to do. So to be honest, once you know, you either plug it into the right spreadsheet or you calculate it yourself if you know the sigma. Don't. So, well, one semi-tricky thing is if you know the population standard deviation, do not use the spreadsheet because it will give you the wrong answer, because the spreadsheet only does it for t-tests when your standard deviation is unknown. So, or paired tests or ANOVAs or that sort of a thing. So what I would like to do, and I'm probably going to do this for the rest of the semester because the next unit, Unit 3, we're going to be doing proportion tests. And so it's really more of the same, but we're just giving you more tests to do. So what I'd like to do, if that's okay with you all, I was going to say you all, but it's just you, Christy, is to go over some examples here and then say which test do you pick, how do you know, what's the null hypothesis and the alternative hypothesis, and then I always like to talk about, do you decide to reject or not reject, and then your conclusion. So one of the things about these scenarios that I do is there's usually not enough information to actually complete the problem. So the purpose of this is just to get you thinking about what are the things that you look for, even if all the information's not there, what are the things that you look for so you know which test to do. Does that make sense?
Yeah.
Okay. So without further ado, we'll just jump in here. Some of these I will just warn you, we may not have learned. I'll try to avoid them, but we've only got a few minutes left here anyway. We'll probably do 1 or 2 here. And then you can see which one to do, or which test that you're supposed to do. So, all right, so Cyrus has a job. Maybe I'll make this a little bit bigger so you can see it. As a quality control for a local grocery chain called Food Giant. His sister Melanie has the same job for a competing chain, which is called Megamart. Cyrus claims that Food Giant gets better delivery times than Megamart on deliveries from Mills Food on their dry goods products. Cyrus and Melanie each select 45 deliveries from Mills Food to their respective stores over the past 6 months and determine the time from order placement to delivery receipt. They want to compare the average delivery times. What hypothesis test should they use? Okay. So before we answer that question, the question that I think that you should all answer is my data categorical, quantitative, or regression? Now, just as a matter of information, categorical is actually going to be Unit 3. Unit 3. Quantitative is Unit 2. That's the one we're on. Unit 2. And regression is going to be Unit 4. Unit 4. So all of the stuff that you've learned for this test is going to be Unit 2. Now, I'm not going to, in our scenarios, just because I want you to get in the habit of this, and also the habit of recognizing, I want you to basically answer, is this categorical? So if it's categorical, we'll kind of stop because we haven't covered that. If it's quantitative, we'll keep going. If it's regression, we'll kind of stop too.
Okay, because I don't know what that is at all.
So, yeah, so that's Unit 4. So as you look through this scenario, does the data to you appear to be categorical, quantitative, or regression?
Quantitative.
Quantitative is correct. Ding, 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 you got the first one right. Okay.
Yay.
All right, so now that it's quantitative, we've got a z-test that we've learned, we've got a t-test that we've learned, and we have, as you're learning this week, the ANOVA test, which the ANOVA test is for 3 or more means, okay?
Okay.
So what I'd like you to do is I'd like you to kind of break it down as to which family of tests this should be. So just as a quick review, how would we know if it was a z-test?
I would need to know the standard deviation, I
So
think.
we would know the population standard deviation.
Yeah.
Now it's a t-test would be
Unknown.
we don't know. And if it's an ANOVA test, we also don't know, but it's also going to be 3 or more means. So based on this, and I'm just going to leave it as those 3 categories of tests right now. Which one of those 3 would you assume that this scenario would represent? T-test because?
Because the standard deviation is unknown.
Don't know the population standard deviation.
Population standard deviation.
Okay, very good. Now that it's a t-test, we have, so you, that was correct. Okay, so pat yourself on the back. You're doing good. Okay?
Okay.
All right, so now we have a 1 sample T, we have a 2 sample T, and we have a paired T.
Okay.
So this is the tricky question. Let's see how you do. Although some people, it's the first 2 and you've done good so far, so.
Well, I don't know because I'm comparing 2 places, but I only see 1 sample. So I don't know. I don't want to get it wrong.
Okay. All right. So, okay, so what we're trying to do is Cyrus claims Food Giant gets better delivery times than Megamart. So Cyrus and Melanie each select 45 deliveries, right?
Okay, so are they collecting them from 2 different places?
So Cyrus has 45 and Melanie has 45.
Okay.
Now they work at different places. So we can kind of throw out this one. It's definitely not a 1 sample T, right?
Okay, right.
Now, this is a good, tricky one because now the question is it a 2 sample T or is it a paired sample T? And I'll let you pick, and then you have to tell me why you picked that. And I'm just going to warn you, without question, this is the hardest choice to make.
Okay. I'm just gonna say 2 sample T.
You're going to say 2 sample T because?
Because one person's sample isn't dependent on the other one's.
Oh, very good.
Oh,
That deserves a big pat on the back there. Good job.
Thank you.
Okay. Easily the most confused one. Okay.
Okay.
All right. Now that we know it's a 2 sample T, I'm going to ask you what is the null and the alternative hypothesis.
Okay, so the null hypothesis, let's see.
This is also a hard question. But it's based, so the answer to this question is based on you correctly picking this. If you get this wrong, you're more than likely going to miss this wrong, but you got that right, so now we'll see how good you do.
Let's see, mu1 is equal to mu2 is what is supposed to be the null, I think.
Okay. Well done. You're 4 for 4. Holy crap.
Okay.
Now, what's the alternative hypothesis?
Um,
And in fact, instead of saying mu1, let's say mu food giant
okay.
versus mu Megamart, just so that it's a little more descriptive.
Okay. And the times, they want to compare the average delivery times. I don't see a greater than or less than. So I would just say mu food is not equal to mu mega.
Now think about it. What does Cyrus claim?
Cyrus claims that food giant gets better delivery times. So it would be food is greater than mu mega.
And better delivery time would mean faster, right?
Yeah.
So it would be less than.
Oh, okay, right.
Yeah.
Yep.
So sometimes you got to think through these logically.
I would have to think that one through.
Yeah. So better food would be faster, so less time. So
faster, so less time.
Megamart. So yeah,
Okay.
that was a little bit tricky.
That's okay. I think I would have got it if I wasn't on the spot.
All right. So now we know it's a T. So can you use your spreadsheet?
Yes.
Yes. So use the spreadsheet. Now we don't have any data, so I'm just going to make up some numbers. So you'll get your T score is going to be whatever it is, 1.23, whatever it is. And then you're going to get a p-value that's going to equal, say, I don't know, 0.03, let's say. Okay. So the next question is reject or do not reject the null.
So don't I need to know the
alpha? Assume the alpha equals 0.05
unless stated.
I don't think this is in these scenarios we'll never. I don't think it ever gives you an alpha. So just assume it's always 0.05.
Always 0.05.
Although in your problems it might not necessarily be. So
right. Okay. But here. Okay. So it's less than. So we reject the null.
Reject the null. Very good. And then, so I know, I will just tell you on this test, they make the conclusions multiple choice, but I don't want to do that. I would rather you just told me what the conclusion is. And in fact, I think this would be better if most people would write your own conclusion before you read theirs, and then that will hopefully help you tell which one is right.
Okay.
So what would be your conclusion? And I always say, and when you do your conclusion, here's one thing that I would just tell everybody. The words I do not want to hear in your conclusion: reject, null hypothesis. I don't want to hear those.
Okay.
Okay.
Yes.
So, I mean, really, this really comes down to what's the claim? The claim is Cyrus gets better delivery times than Megamart on dry goods products. So really, when you're doing your conclusion, address this claim. So is Cyrus right or is Cyrus wrong?
So I would say we have sufficient evidence that Cyrus gets better delivery times than Megamart.
Food giant gets better delivery times than Megamart.
Is that right?
Well done.
Okay.
I can't believe this because this is the first time I've done. Now, normally I would have done them last week, but as everybody knows, my dad passed away, so I didn't do an office hour. But nobody ever gets this right on the first time, and you did everything right except for maybe this one, but that was a little tricky. So well done. You deserve 2 pats on the back for that.
Yay.
So very well done. I am impressed. Okay.
Thank you.
Do you want to do another one?
I don't know. It's so stressful. Only because I know you're going to post it.
Well, look, I did awesome. So how good I did. And then you can say, and study with me because I know what I'm talking about. All right. So this one is a purposely tricky one. They inserted some words just to make it purposely tricky.
Okay.
So I'll just warn you to be careful on this one because it's tricky. Ted is a medical researcher who wants to monitor the blood sugar of some patients in a study. He is concerned that these patients might have a higher blood sugar than the general population. His research tells him the average blood has a glucose level of 84 milligrams per deciliter with a standard deviation of 5.2 milligrams per deciliter. For his study, he is studying both the husband and wife of 22 couples in the patient group. What hypothesis test should Ted use? So before I answer that question, in fact, I'm gonna copy a lot of this stuff. I'm gonna copy these and then I'm gonna erase all the answers. In fact, I won't even copy that because I don't want to do that. Okay, so the first question you should always ask yourself, is it categorical? In fact, I'm going to get rid of all this stuff. Quantitative or regression?
Quantitative.
And you say it's quantitative because?
Because there's numbers I could work with.
Because there's numbers. Yeah, so we're looking, yeah, 84, that would be a regular number. Okay, so quantitative is correct. Good job. Now, the question is it a Z? And I'm going to erase my little hints here.
Okay.
Is it a T? Or is it, and ANOVA is actually, I usually say F. F is the ANOVA test.
Oh, okay.
Okay, so yeah, you'll learn that today or this
Okay.
week.
Okay.
And so your answer is?
My answer is Z because there's a standard deviation given.
You are doing amazingly well.
Hey.
So yes, most people guess T and you guess Z, so that's correct. So now the nice thing about this test is you've only learned one Z test, and it's the one sample mean. However, just as a preview, there is also a one sample proportion, and there is a two sample proportion that are all Z tests.
Okay.
Okay, so
that'll be in Unit 3.
So that'll be in, so those, yeah, these two will be in Unit 3. So I don't want to give away to you. So I'm going to give you the choice there. What do you think this is a one sample mean, a one sample proportion, or a two sample proportion?
Oh, one sample mean.
One sample mean, very good. Sample mean. Okay, so yeah, you're doing awesome. All right, so now the question is, what is the null and the alternative hypothesis?
Well, mu would be equal to 84.
Okay.
And the alternative hypothesis is mu. This is greater than 84.
Very good.
Okay.
Really, two pats on the back. Nobody does this well ever. Okay. Now,
Thank you.
I want to point out to you, because I know there's probably some people that are going, wait a minute, why are we saying this is a Z? It says husband and wife, 22 couples. Why is that not a paired sample distribution? Can you answer that question?
Because you told me to first ask myself if it's a Z test or a T. So since it's a Z test, then I think the rest of the information just, I don't want to say it's wiped out, but
it was there to mess you up. And it
it was there to mess you up. I'm following instructions.
Yes, you're doing very well. Yes, because you saw here that we're looking at this. His research tells him that it has a standard deviation of 5.2. So we're referring to that. So it doesn't specifically say the word population in there, but we're assuming that's a population, and we're assuming that this value is a population. So the one thing, because we actually have specific numbers here, 84, that's another clue that you're going to set your null hypothesis to a specific value. If it was a husband and wife, 22 couples, instead of doing this, I would say mu sub D equals 0, because we're going to say there's no difference. With a paired sample t-test, it's always mu sub d equals 0. Does that make sense?
Yes.
Okay.
I mean, I actually don't know why, but I do know that that's what I learned.
Okay. All right. So yes. So the whole point is here, because you pick the right test here, you therefore pick the right test here. You therefore got this right. So you can see on this test, if you mess up like here, oh, you're in trouble for the rest of the problem. This really cascades. So that's really why this test, because they're going to give you a scenario like this, and then they'll be like, no, the next 5 questions are based on this question. So if you blow this, oh man, it's brutal. Okay. Now the next question is, can I use the spreadsheet?
No.
No. Very good. Because people will go, well, yeah, I can put that in there. No. The spreadsheet calculates the standard deviation yourself. Okay. So no is the correct answer. Okay. There's a lot of people that are like, oh, I can use the spreadsheet for everything. Not on a 1 sample mean. Now, just FYI, when we move into Unit 3, they have a special spreadsheet for these 2 tests. And so you will be able to use the spreadsheet, but there is no spreadsheet for a 1 sample mean with z-test. Okay? So, well done. Now, let's say we get a t-score equal to, or a z-score rather, equal to, I don't know, 0.123. This time I get a p-value of 0.15. We'll assume my alpha is the same. Reject or do not reject the null?
Do not reject the null.
Do not reject the null. Very good. And so therefore your conclusion is?
I have insufficient evidence. Now I got to read the question again because.
Yeah, I know. Here, let me make this a little bit smaller. Hopefully we can get everything on the same page. Oh, sorry. No, I can't fit it all on the same page. Okay. Could you see?
I have insufficient evidence that the average adult blood glucose is greater than 84.
Very good. You're doing awesome.
Is that right? Okay.
Yeah, I mean, and I know they love to get into this recipe, but I would say what you said was correct. But here's a less clunky way to say it. There
Okay, yeah, tell me.
Enough evidence that the patient group is higher than the population for blood glucose level.
Okay.
That's more clunky, but what you said was correct. And in fact, what you said is more likely to be one of the options that they will choose in the multiple choice. So they'll probably say there is insufficient evidence the patient group is higher than 84 milligrams per deciliter. So.
Yeah. So you know that testing means flow chart that you gave us?
Oh, I'm so
Is that something that we'll pull up?
So since you mentioned that, let me throw this out here. So I believe on this next thing, you can have 1 page of notes. However, here's a bonus, just especially since you asked the question. Here it is. So if you go down, if you're in the table of contents, you go down to resources at the very bottom. You go to the flow chart here.
Oh.
Okay. Now, the flow chart. Yeah, that's the second one. So here's what you can do. This is blank. It's not filled in. And it's going to open. Okay, so here's kind of in a nutshell what I just asked you. Is it quantitative? Is it categorical? Is it, well, regression? That's really should say regression, but two quantitative variables is what it says there. So then once you answer that question, so then you can say, well, is it a one sample Z? No, actually it says, is it a one sample test, a two sample test, or a 3+ sample test? So you can fill this out yourself. Now, pretty much this unit here, we're only going to cover the quantitative. Unit 3, as I mentioned before, is categorical, and then Unit 4 is going to be regression. But if you want to fill this out, so 3+ samples, that would be an ANOVA test. Oh, I can't edit this. So you can type in here, this is the ANOVA test. And then, so for example, if the sigma is known, this is a what?
Z.
One
Test.
sample Z.
Oh, yeah.
And if the sigma is unknown, it's a
one sample T.
One sample T. And so let's say you have two samples and they're dependent samples. What is the test?
Paired, what do we call that? T-test?
Paired T-test. If it's independent samples, it is a
samples T-test, or do you say two?
Two independent samples, T.
Oh, okay.
Okay. Now you can also add in some details down here. Now this does not count as your one page of notes. This is like bonus material.
Oh.
Yeah. So
Yay.
although I would say if you had this, you wouldn't need a page of notes anyway.
Okay.
But some details. So for example, how big should your sample size be for a one sample?
What was that?
How big should your sample size be for a one sample Z-test?
What should your sample size be greater than 30? Is that what you mean?
So yeah, and greater than.
I think you bleeped out a little bit, so I didn't quite get your question.
Oh yeah, you got that right. You answered it correctly. So n greater than 30 or QQ plot, or it says that it's normally distributed.
Yeah.
If it says that the population is known to be normally distributed, you could get away with one, although I don't know anybody that in their right mind that would actually do such a thing. Okay. Or if you have if it says in the problem it's normally distributed, actually you don't need to worry about any of this.
Right.
Okay. If it doesn't say that, then you should either have it to be greater than or equal to 30, or you should get a QQ plot that looks normal. Okay. The null hypothesis in this case, and I'm not going to do all of these, but I'll do this first one. So what should your null hypothesis be? The alternative.
It is the mu is equal to sample mean, or
some sort of a number.
X bar?
No, not X bar. It's always
not X bar.
Yeah, so you should never use X bar ever in any.
Oh, it's the number, right?
Because the hypothesis is always about the population. Okay.
Population.
So the idea here is you can put in any details here, and then your alternative will be either mu is less than or greater than or not equal to whatever that same number is.
Okay.
And so if you want to fill this in for each of these, and we're out of time, or I would go do that, but you can do this.
Yeah.
Basically, you only need to worry about these 5 tests here. Whoops, didn't mean to move that. But the ANOVA, everything in here. So the ANOVA, just one of those details is we have to assume that the largest standard deviation is less than 2 times the smallest. Okay?
Yes.
So that's another.
I haven't learned that yet.
But that'll be one. So things like that that you need to you'll need to remember. So yeah, this can be super helpful. They want you to fill this out because they think you'll remember it better if you fill it out. But I gave you a few things that are helpful.
Yeah.
So.
Okay, so quick question with the sample. If they don't give a sample size like n, then you or normally distributed, then you go to your QQ plot. That's the order of how it works, I guess, right?
Well, you pretty much should always know your sample size. I don't think they should always give it to you. But the question is, if we go back to this one sample Z, they don't tell you it's normally distributed, and they have a sample size of 11.
So then I'd need to go to my QQ plot.
Is that big enough?
No.
Not really, but you can get away with a small sample size if your QQ plot is normal.
Okay.
Okay. Yeah. If they give you a sample size of 50, is that big enough?
Yes.
Yes. Now, having said that, here's what I want to just emphasize. A lot of times on the test questions, you'll just assume that, oh, it's 50, it's big enough, okay? Now, we're going to be coming up in Unit 2, we're going to be coming up with our projects here. What I would like to emphasize is a lot of students, when they're doing their projects, say, oh, we're going to get a sample size of 50, therefore, according to the central limit theorem, it's automatically normally distributed. No, there's nothing automatic about it, okay? The fact of the matter is you could have a sample size of 100 and it might not be normally distributed. So 30 should be recommended as a guideline. On your test, a lot of times, if it's 30, you'll assume it's normally distributed, but in real life, you should always do a histogram and or a QQ plot to make sure your data are normally distributed. And so 30 is kind of the low end of it. You should never, so 30 is the smallest it should be to get away with it. But you know, it could be several hundred and still be and not be normally distributed. So central limit theorem isn't automatic. It must be backed up with either a QQ plot or a histogram that verifies that your data are normal. So don't think 30 is this special magic number. And oh, by the way, you don't need to worry about this for this week's test. N equals 30 does not apply to categorical data. I have a different formula for that. So I'll say that next week so I don't mess you up there. So
okay, good. Don't mess me up.
You'll probably want to figure out what that is, but it's not 30. In fact, 30 could be way too small for a categorical test.
Okay.
Okay.
All right.
All right. Any other questions?
Nope, that's good.
All right. Well, you're golden. Everybody who's watching this after should study with Christy because she knows what she's doing.
No, but I have a very good group. We'd study good together.
All righty. Thanks. Well, will I see you on Thursday?
I will probably be studying for my test, but
okay.
Yeah, but
if you have any questions, come back and
okay.
In fact, we'll do way more scenarios. We only did 2. I've got like 17 pages worth of these. So
okay.
We will not do all of these this semester, but we'll do a lot of them.
Okay. All right.
So, and then we'll probably start mixing in some categorical ones just to keep you on your toes.
Okay. Thank you.
All right, then. You're welcome. So I'll let you go. And you have a great week.
Okay.
And good luck on your test.
Take care.
All right.
Thank you.
Thank
you.